Hello everyone, this is Pooja Nair and today we are going to do the first exercise. Our aim of the first exercise is to read and analyze data, handle missing values by using various methods: discretization, that is binning, normalization, sampling, and correlation determination. So to start with, we have to import our data. To import our data, we create our repository by clicking the drop down menu, click on next, and give any name for your repository. For example, I gave it as NOP and click on finish. So here I have my new repository created. Under this repository we need two subfolders, that is data folder and process folder. So I right click on it, create subfolder, name it as data, and we need yet another subfolder, that is process. Click OK. Now we have our new repository as well as the two subfolders under it. So in order to add our data, we click on this repository, and further clicking on add data, click on my computer. Well, I have a file stored in desktop, so I click on desktop and yes, auto CSV. Click on next. Now here we have our data set present. This data set is related to the automobile data, and here we have headers like attribute 1, attribute 2, attribute 3, etc. You can see that each attribute has a data type of its own. For example, attribute 1 here has a data type of integer because it has values like 3, 1, 2, 0, etc. And attribute 2 is given as polynomial as its data type. But when we look at its value, we have 164, 158, 192, which are not polynomial but they are integer. So we change the type to integer. And similarly, we check on further whether there are any errors. That is, if we have to change the data type. And as we go on, yes, we see here we convert the type into real. Similarly here too, we change the type into real, and at last change the type to integer. Yes, now it's done, and here we have 36 errors present. We tick mark this and click on next, and I have to store my data in data folder. I click on it and click on finish. So finally I have imported my data into the repository. So you can see here under attribute 2 there are question marks given. These are the null values, that is missing values. If you look at the statistics, we find that attribute 1 has 0 missing values. Its minimum value will be -2 and maximum value is 3, and also the values average is also given as 0.834. Similarly, for attribute 2 we have 41 missing values, and as we move on further, we find that for attribute 19 we have 4 missing values. For attribute 20 we have 4 missing values. Similarly, for attribute 26 we have 4 missing values. So as we have imported this data, we'll be handling these missing values. So we can handle these missing values using two methods. Either we remove the records or entries from the example sets totally by using filter examples operator, or else the second method is using replace missing values operator, in which we replace the missing values using average, minimum, or maximum. So we'll be looking into it now. We just drag and drop our file. Yes, we have done it. Now yes, By using this filter example, we can delete or remove the records or entries having missing values from the dataset example. By clicking on filter examples, we see on the right hand side we have certain parameters, condition class. So if you click here, if you want a set or the result with no missing values, we click on no missing values. If you run it, we find that our original set actually contained 205 examples, and on running this filter examples we get 160 examples. That is, the number of examples are reduced, which means that the null values that are present here, that is a question marks, they have been totally deleted. This is one way of handling our missing values. The second way of handling our missing values is we can use replace missing values operator. Yes, we have here. Connected. On clicking missing values, here we have retrieve auto. That means we have the example set stored in this retrieve auto, which gives the example dataset as output to the replace missing values, where we have certain parameters like attribute filter type. If you want to select all the attributes and apply the changes to it, we select all, or else if you want to change single attribute at a time, we click on single, and we further select the attribute which I want to replace the missing values. For example, I replace attribute 2's missing value. We have default. I replace it's given average. We have minimum, maximum, zero, value, anything. We can choose anything as per our convenience and the need. So here I choose average. So by choosing average, it means that the missing values will be replaced by the average value of the attribute. So when we look at the statistics, attribute 2, it has now 0 missing values, and the missing values have been replaced by 122. That was its average. Further, we can do changes to other attributes as well, like attribute 9. Attribute 19, if we run it, see that attribute 19 this attribute 9 has got 0 missing values. And similarly, if you want to remove the missing values for all the attributes, we can click on all, just run it. We get 205 examples in total, and the statistics we have 0 missing values for everything. The missing value will be replaced by the average value. If you want the missing values to be replaced by minimum or maximum, we can do that as well. And in data sets having huge number of examples, we can use an operator called select attributes, which will be helpful. So this was our part of handling missing values. Second part is discretization. Discretization operator discretizes the selected numerical attributes to nominal attributes. So the operator we use will be discretize by frequency. There are many methods, operators like discretize by size, by binning, by frequency, by user specification, by entropy. Here I'll be using discretization by frequency. So I'll be connecting these ports. Yes, and this discretization in real time can be used. For example, if I have a data set of a group of people, and if I want to arrange their age, average age, into small intervals, then we can use this discretization, which will help us arrange their age into smaller intervals. So here on looking into its parameters, we have attribute filter type, we select single, and for the attribute, for example, I select attribute 2 and number of bins as 3, and if we run it, yes, we have for attribute 2 we have got the range. If you look at the statistics, we have attribute 2, we have the value specified over here, that is, if you click on details, we get 3 bins are created. First range is negative infinity to 105, second 105 to 126.5, and third is 126.5 to infinity. So in this way we can do it for other attributes as well, and we can increase the size of bins or decrease it as per the data set given. Similarly, we can use yet another parameter, that is normalization. We connect it. This normalization parameter actually is a technique that is used to rescale attribute values to fit in a specific range. This normalization technique is used in order to make a fair comparison between the values of different attributes. So after we connect it, and we see at the right side we have several parameters, and if I select attribute filter type as single, attribute as 1, and transformation as range transformation, for example, and if I run it, so here minimum value and maximum value is specified. It means that if I run this, then the values of the attributes will automatically be converted into forms which will be between this 0 and 1. If I run it for attribute 1, yes, you can see here the values, all the values are ranging between 1 and 0. Here for attribute 2 we have 122, 122, 164, etc. So if I change it for attribute 2 and run it, see, for attribute 2 we have all the values now in the between 1 and 0. Now moving on further to sampling, which is a very simple process. Sampling is used in order to get a small subset from a large set of data. For example, if I have a data set of 500 examples and I want to analyze the data for only 10 such rows or examples, then I can use sample and get the subset from it. Here if I click on sample, I have sample size. For example, I just want 5 rows to be displayed. I just want to do analysis on 5 rows. So if I give 5 here and if I run it, I get 5 rows and I can do the analysis based on it on a small set of data. And if I want our sample size to be 10, if I run it, we get 10 rows. So that is related to sample. So till far what we have seen is we have read and analyzed our data. We have handled our missing values using either by removing records or entries that has missing values using a filter example operator, and the next method was using this replace missing value operator, that is this one, and using this we can replace the null values with either the average or minimum or maximum of the attribute. Then we dealt with binning. For example, that I told you in real time, if I have a data of several people and if I want to arrange their average age in terms of small intervals, then this binning will be useful. It can be applied in many other areas as well. Then we had seen normalization, which is very well used for a fair comparison between attribute values. And then we saw sampling just now. Sampling is a technique which is used to derive a subset from a large number of values or data. And next we are going to see correlation determination. Correlation determination is actually, it gives us a relationship between two attributes. It shows us the relationship between two attributes I've selected correlation matrix as the operator. I'm connecting it now. So here, instead of taking this automobile data, I'm going to take a data which is in real time, like I'll be adding yet another data set. Yes, downloads, I have it in downloads. Yes, there we go. Now we have our data set over here, and this is the header that is highlighted at the top. That is insulation, temperature, heating oil, number of occupants, average age, and home size. This is a data about a home, like the home size, how many members are there, how many occupants are there, their average age, the temperature inside, insulation period, and heating oil. So depending on this data, we arrive at a decision using this correlation matrix, and I'll just show you how to do that. We click on next. Here everything, the data types are all perfect. Click on next. Storage and data. Click on finish. Yes, these are data, 0 missing values, so fine. We move on to drag and drop this data, connect it to replace missing values, and this replace missing value operator is not needed right here because we don't have any missing attributes. And this correlation matrix, we have yet another port as output, because the first port gives us the summary of the data set, which will be very much similar to the example set, the real example set. And the second one is the port which gives us the actual result about the correlation matrix. Now if I run it, yes, we get the matrix. This is the correlation matrix. This is a 6x6 matrix. If we take a look, we can see that the values in the diagonal are all 1. It means that a correlation matrix actually has 3 values, important values: 1, -1, and 0. 0 stands for no relationship. 1 stands for a very strong positive relationship, which means that if a value of a particular attribute increases, the value of the other attribute also tends to increase. And -1 means it is a negative relationship. That means that if the value of an attribute decreases, then the value of the next attribute tends to increase. For example, I'll show you here: temperature and insulation. Here the diagonal elements, first of all I'll tell you why the diagonal elements here are 1. That is because the value of 1 corresponds to insulation and insulation. It tells us about the correlation between insulation and insulation. Obviously both the attributes are same, so the value will be 1. And then temperature and insulation has a negative correlation. Why? Because if the value of 1 increases, if the temperature increases, the insulation period decreases, means we have a negative correlation over there. Here if we see, we have heating oil and insulation. We have a positive value, a strong relationship, that is 0.736. It is because when the insulation period increases, period of insulation increases, more heating oil is obviously required. So the usage of heating oil is more, and so is the relationship denoted here as positive. Here as we see, the relationship between heating oil and temperature is minus 0.774, means a negative relationship. It is because as the temperature increases, as the temperature becomes hotter, so we tend to use less heating oil as compared to when we use cold climates. Now looking for the heating oil and average age, we have a very strong correlation, that is 0.848. That is because normally elderly people, if they are at home, they tend to live in a very warm environment, and so the usage of heating oil is more. Further, we can plot the charts using scatter. For example, I use the x-axis as I use x-axis as insulation and the y-axis as heating oil. Yes, we can see here that for small values of x we have low y value, right? And as the insulation becomes older, more heating oil is used, and that is seen from this graph. Now if you change the x-axis to average age and the y-axis to heating oil, this shows us that as the average age of a person increases, that is in the shown in the x-axis, as the average age increases, people tend to use more heating oil. That is clearly seen from the growing graph. And then if you change the x-axis to temperature and keeping the y-axis as heating oil, it shows that as the temperature increases, this region, as it became much hotter, 80, 85, 90, it shows that the consumption of heating oil is very less. So in this way we can come to several decision making. This is one such example. There are several real-time examples in which we can use this correlation matrix to determine the relation between two or more characters. We can also plot it using scatter 3D. For example, we have x-axis as insulation, z-axis as heating oil, and y-axis as temperature. Yes, we do have a graph over here, and we can move this obviously around. By moving this around, we can see here x-axis is insulation, z-axis is heating oil. It means that as the insulation period increases, the amount of heating oil used is more. That is a positive correlation as a 3D representation. Further moving, we can also see that this is now y-axis and z-axis. In y-axis we have temperature and z-axis we have heating oil. So this graph, this 3D view depicts that as the temperature increases, the heating oil consumption decreases. The hotter the temperature, the lesser is the heating oil used. So in this way you can change the x-axis and y-axis as well as z-axis and come to several conclusions. So this was all about correlation determination, and we can make, as you have seen, we can make different determination and relationships between two attributes, and we can arrive at any conclusion or decision making. So I hope this video was useful. Thank you.